Alright, today I will demonstrate how to calculate um, velocity, time, and all the other components based off the initial given time, initial velocity for x, and acceleration for the vector. Our particle starts off at the origin, so we can assume that x initial and y initial are both 0 meters, and we are given velocity initial as 20 meters. Our time is 0, so we can draw up a chart labeling our vector, and we can move on from there. We know we are asked what the time is when the particle reaches 50 meters, so we can use our basic kinematic equations to solve for this. We take y squared, y2 to solve for, since we know the original velocity, position, and acceleration of it. We just plug those in, and most of them are 0, so all we're left with is the second half, which is velocity or acceleration times time squared times 1/2. So we solve that, and the time that the particle equals 50 meters is 4.4 seconds, and then we can move on to solve for the position of x at this given time. So we're not sure of the second x position, so we can use the same kinematic equation as we did before and plug in all the numbers. We're solving for x2 this time, so we just plug and chug all those, and our x2 is 1 of 9.4 meters. Now that we have both the time and the distance, we're able to solve for the velocity of each vector. So we'll solve for the velocity vector first. We know the initial velocity, acceleration, and time, so we'll use another basic kinematic equation and solve for that. We just plug those in and get 28.9 meters per second for the velocity of x. We do the same for the y velocity too, and we're given the initial velocity, acceleration, and time we solve for, so we plug those in and get the y velocity of 22.4 meters per second. Now for the velocity vector, we could draw it up as a triangle and label our velocity vectors for x as 28.9 meters per second and our y velocity as 22.4 meters per second, and use the basic Pythagorean theorem to solve for this, so we can square each of our axes and then square root that to get the velocity for the total vector, which is our hypotenuse. So we get 36.56 meters per second for the vector, or we could write that as 28.9 meters per second x hat plus 22.4 meters per second y hat. And that is how you solve a vector problem given time, acceleration, origin, and initial velocity for one x or y.